Okay, so imagine this. Maybe you've been there. You're working on your RC car, front wheel axle's popped off, and you're fighting with this tiny 4mm Nylock nut. You grab your needle nose pliers, try to hold the axle still, and nope, it just spins. Frustrating, right? But then maybe you grab those specialized RC shock pliers, clamp down, and bam, it holds. The nut comes right off. Today we're doing a deep dive into exactly why that happens. What's the actual physics and engineering going on there?
Yeah, it's a great example. And it's less about just a stuck nut, it's really a work holding problem. And it perfectly highlights the difference between a general all-purpose tool and something designed for a very specific job. There's some clever engineering hiding in plain sight.
So let's start with the villain of the piece, maybe. That 4mm Nylock nut. It's not just a standard nut. It's called a prevailing torque lock nut. Sounds serious. It's built specifically to resist vibration, right? To stay put.
Exactly. That's its job, especially with all the shaking and shocks an RC car goes through. The key is inside there's a little ring of polymer, usually nylon, like Zytol 101, and it's actually slightly smaller than the thread diameter. So when you thread the axle in, it forces its way through that nylon. It doesn't cut threads. It deforms the nylon both elastically and plastically. This creates this constant squeezing 360-degree grip on the threads. That's the prevailing torque. Even on a small nut like this, it generates significant resistance. You need a solid counterhold to beat it.
Okay, which brings us back to the tools. Needle nose pliers, everyone's got a pair. Super handy, long jaws, usually flat surfaces inside. Great for fiddly stuff. But why do they fail so badly on this round axle?
Well, it comes down to the physics of the grip. Those flat jaws, even if they're serrated, only make contact with the round axle on, like two very narrow lines or tiny patches. So the clamping force you apply with your hand, the actual normal force pushing the jaws into the axle surface is roughly the same. And the static friction you get depends on that normal force. Here, it's just, well, it's not enough. The prevailing torque of the Nylock nut is stronger than the friction the needle nose can generate. So, slip.
Right, it just spins. Okay. But then the RC shock pliers come in. They often have those V-shaped grooves or maybe some of the circular cutouts machined into the jaws. That's the magic.
That's a huge part of it, yeah. That V-groove, typically maybe a 90-degree angle, it acts like a force multiplier. Think about the geometry. When you squeeze the handles, the force isn't just pushing straight in like the flat jaws. The angled faces of the V direct the force more effectively onto the axle. A bit of vector analysis shows that for the same squeeze, you get significantly more normal force pressing into the axle, maybe around 40% more. More normal force means much more potential static friction, enough to overcome the nut's torque. It's clever design.
So it's geometry amplifying the grip. Is that the whole story, or is there maybe something about the materials too?
Good point. There's definitely another layer. It's the material interaction. Your decent pliers are made of hard tool steel, right? Rockwell hardness maybe in the high 50s or 60s. But the axle itself is usually a much softer steel, probably below 40 HRC. So when those V-grooves on the shock pliers apply that amplified force, the harder steel of the pliers actually bites into the softer steel of the axle, just a tiny bit. It causes microscopic plastic deformation on the axle surface, creates a kind of mechanical interlock. This effectively increases the coefficient of static friction. Those little marks you sometimes see on the axle afterwards, That's the evidence. It shows the tool actually dug in slightly, which helped it hold.
Okay, that makes sense. Harder tools biting into softer bar. So what if you're stuck? Axle spinning, no shock pliers in the toolbox. Any other tricks?
Well, yeah, there are options, but they have downsides. If you have enough thread showing, you could try the jam nut technique, thread another nut on and tighten it against the first one. That's probably least damaging. You could use locking pliers like vice grips. They'll likely grip it, but because they clamp so hard, they will almost certainly chew up that softer axle shaft. You'll see marks. And then there's destructive removal, last resort, like carefully cutting the nut off with a Dremel or rotary tool. High risk of hitting the axle threads, though.
Right, got to be careful there. And just quickly, for the original problem, fixing that axle that came out of the steering knuckle.
Oh, yeah. For that kind of repair, something like a steel-reinforced epoxy, JB Weld is a common one, usually works really well. The absolute key there is surface prep. Clean everything meticulously, maybe rough up the surfaces slightly with sandpaper. That gives the epoxy the best chance to form a strong, lasting bond.
Gotcha. So pulling it all together then, those RC shock pliers work so well because it's this neat combination of smart geometry, the force multiplying V-groove, and material science, the hard plier steel, biting into the softer axle. It's not just squeezing harder, it's squeezing smarter.
Precisely. And, this whole scenario, it really drives home the point that understanding why your tools work the way they do, the principles behind them, makes you a better technician, a better problem solver. You start seeing the hidden engineering in all sorts of things.
It makes you appreciate the design that goes into even simple tools. So maybe the next time you pick up a tool, think about it. What clever engineering principles might be at play, just waiting for your own deep dive.